We are starting what I'm going to be calling Chapter 14. It's not in the pre-calculus book. It's actually Chapter 14 out of your Algebra 2 book. Basic trig identities. Today's date is today, and our objective is to verify and simplify trig expressions using reciprocal and Pythagorean identities. Well, most of these really should look familiar. What they're doing now is just kind of giving you them all at once and saying these are your identities. And what we're going to do is we're going to use these identities to help simplify other expressions. Your reciprocal identities, cosecant is 1 over sine, secant is 1 over cosine, tangent is 1 over cotangent. And the same thing, sine is 1 over cosecant, cosine is 1 over secant, and cotangent is 1 over tangent. You will need to have those memorized. You also need to know what we call the tangent identities. Tangent is sine over cosine, and cotangent is cosine over sine. So, if I wanted to verify this identity, when I'm verifying an identity, I choose one side, and that's the side that I'm going to work with. I'm going to leave the other side alone. So I'm going to make this left-hand side look like the right-hand side. And I have found in the past that it's usually the easiest if I try and write everything in terms of sine and cosine. So I'm going to leave that sine theta how it is, and that cosecant can be written as 1 over, did I say cosecant? I'm sorry. That secant can be written as 1 over cosine theta. And that is all still equaling the tangent theta. Well, if I multiply those two together, that's the same as sine theta over cosine theta. And from our identities, we know that sine theta over cosine theta equals tangent theta. So that would be the same as tangent theta equals tangent theta. And we just proved that the left-hand side equals the right-hand side. Let's do another one. We want to verify that cosecant theta over secant theta equals cotangent theta. Well, I'm going to choose to work with the left-hand side. I know cosecant is 1 over sine. And I know secant is 1 over cosine. It doesn't really look any better at this point. So let's take that compound fraction or that complex fraction and simplify it down. That's really 1 over sine divided by 1 over cosine. Remember, when we're dividing by fractions, we're actually multiplying by the reciprocal. So that's really 1 over sine times cosine over 1. Again, we're trying to prove that that equals cotangent theta. Well, let's go ahead and multiply. And I'm going to get cosine theta over sine theta equals, that's supposed to be an equal sign, cotangent theta. Just a second. Well, and from our identities, we know that cosine over sine is cotangent. So we just proved that one side equals the other side. All right. On this one, we want to prove that cosine squared theta plus sine squared theta equals 1. If you notice, I have two equations written here. Those are actually the same thing. It's two different ways of writing it. However, when I have a cosine that's squared, I'm going to write it in this fashion right there on the right-hand side. Well, I thought the best way to show this was to actually visually see it. So I drew our unit circle. I didn't put any of the measurements on there. But then I drew an angle, and I called it x and y. The ordered pair on the circle would be x and y. Well, we know cosine is x coordinate, and we know our y is our sine coordinate. So you'd have x squared plus y squared equals 1. Think back to geometry. That is simply the Pythagorean theorem. A squared plus b squared equals c squared. In this case, our c is the radius of the circle, which is 1. Our x is that length. Our y is that height. So we have a couple different variations of what we're going to call the Pythagorean identities. If I were you and taking notes, I would probably pause on this for a second and make sure you have these copied down. You will be using them quite a bit. So let's go ahead and simplify this one. Again, one thing that I said that will help out is try and get everything in terms of sine and cosine. So sine, I'm going to leave that alone. Cosecant is the same as 1 over sine. And I'm noticing before I do anything that those are going to be canceling. So I'm not going to do anything with that cotangent for the moment. I'm just going to leave it like that. Because sine times 1 over sine is just going to be 1. And I have 1 over cotangent. Well, look at your reciprocals. That is the same as tangent theta. Let's do another one. On this one, I've got cosine theta times cotangent theta times sine theta. I'm going to leave the cosine as it is. I know cotangent is cosine over sine. And I'm going to leave the sine the way it is. It looks like I forgot to write my theta there. If I'm going to make a mistake, that's usually what it is. Well, what happens are those two sines cancel. Cosine times cosine is going to give you cosine squared theta. Let's do another one. All right, I'm going to leave that cosine the way it is. Just a second. All right, and as I said, I always want to put things in terms of sine and cosine. So I'm going to leave that sine alone. Tangent is sine over cosine. So when I simplify that, I'm going to get cosine theta plus sine squared theta over cosine. Well, I've got things that are being added together and they're fractions. And remember, whenever you're multiplying a fraction, you have to get a common denominator. So what I'm really doing is I'm multiplying that by cosine over cosine. And of course, that would be over 1. So I'm going to get cosine squared over cosine. Oops. Let's change the thickness of that back. All right, now I have the same common denominator. I'm going to add those together, and I'm going to get cosine squared theta plus sine squared theta all over cosine theta. Well, that's one of our Pythagorean identities. We go back a page and look at that. Matches up right there. We know cosine squared plus sine squared is 1. So what I really have is going to be 1 over cosine and from our reciprocal identities, we know that 1 over cosine is secant. So once we simplify everything, that should be our final answer. I hope you enjoyed.